Okay, so this is chapter 3, problem 31. This is recording number 2. Okay, so I think where I left off here was here's a close-up of this point that I'm interested in. I'm interested in the 2 points I'm interested in. I'm interested in this line segment. The line segment between here and here, and that comes from up here. Gosh, this is harder than it looks, folks, to keep this organized. Okay, so that comes from this percentile or the percentile graph that we have. We want 22, so 22 percentile is somewhere between this point that we plotted and this point. It's somewhere in here, right? So that's 22 is between this guy 45.5 12 and 50.5 44. Okay. Okay, so 31b, we're trying to find the value in the scores that corresponds to the 22nd percentile. Alrighty, so we look at the graph again. These are the 2 points that we're looking at. I just talked about that. We want the score that, hold on one second here, get rid of this. Wait a second, I don't know what that is. Hang on one second. Okay, so we know the score that corresponds to the 22nd percentile, or we want the score that corresponds to the 22nd percentile. We know the values for the 12th percentile, and we know the values for the 44th percentile. So we want to get the guy that's between the 12 and the 44. Therefore, we want the guys that are between the scores that are between 45.5 and 50.5. We want the score between that. Okay, so here's a close-up of that. Okay, this is just to illustrate my point, and that is that when we graph this, this is the line segment that we're interested in. This delta x is the delta, the change between 45.5 and 50.5. This delta y is the difference between 12 and 44. Okay, so delta x is 50.5 subtract 45.5, which is 5. Delta y, 44 take away 12, which is 32. So that's my delta x and my delta y. So delta x over delta y is 5 over 32. Okay, so what does this mean? It means that for every unit change in y, we get a change in x of 5 over 32. Now that seems totally bizarre, right? But it's not. I swear to you, it's not. Think about it this way. If I said to you, you got 25 miles per gallon of gas, okay? Or let's say you were driving your bicycle or you're driving your car at 25 miles per hour. And okay, so 25 over per hour. So what does that mean? That means per 1 hour you travel 25 miles. Well, suppose you traveled half of an hour, 0.5. You'd multiply 0.5 times 25, you'd get 12 and a half, and you'd say, okay, in half an hour, I only went 12 and a half miles, right? Well, it's the exact same concept here. For every unit change, for every hour that you drive, you go 25 miles. Here, for every unit change in y, we're going to get a change in x of 5 over 32. Why? Because it's delta x over delta y. The change in y gives me a change in x. It's 5 over 32. That's the ratio, okay? All right, so now we're ready to solve. We want the value that corresponds to 22. 22 is in units. I'm sorry, 22 is 10 units more than 12. So when we go from this point to the unknown point, we go from 45.5 comma 12, we go to some unknown point. That's what we're looking for, this guy right here. And that corresponds to 22 in percentages. How far do we go? We go 10 units in the y direction. We go from 12 to 22. Okay? So look at your cartoon. I can't keep going back to the cartoon. It just takes too much time. Okay, so since delta x over delta y is 5 over 32, how far do we go? It's 10 times 5 over 32, okay, in the x direction. Well, 10 times 5 over 32, it was easier on my calculator to make it into decimals. I multiply that out, and that's 1.56, blah, blah, blah. Close enough for government work. We're going to make that 1.5, okay? So we go from 45.5 to 45.5 plus 1.5. That's how far we go in the x direction, which is 47, which is the correct answer. Okay, now how do I know that's the correct answer? It's in the back of the book. The correct answers are in the back of the book. But also, I have the instructor's edition. So just to help us instructors, they actually write down. They give us the answers right there with the problem. So what I put here on the front page, these numbers right here, these numbers right here, these are the correct answers. Okay, so I know I got it right. It's 47. Okay. All right. Okay, 31C is the same concept, okay? Because in 31C, we're going in kind of in the other direction, so to speak. Okay, in 31C, we want to find the percentiles of the values. In other words, give me a value, give me a score value of 52, a score value of 43, and so forth. How do I find the percentiles? Well, you can do it with graphing, like that's on the bottom of page 152. You start at the horizontal axis, you go up to the graph and go to the left. So that's how we did it before. That's how the book kind of expects you to do it. Okay, so you start here at 52, you go up, and then you go to the left. But we're going to do it in a slightly more scientific, analytical way by using this delta y over delta x business. Okay. All right, so I just did it for 31B. 31C is the same concept, but we're going to multiply by delta y over delta x. Okay, so I'm going to leave that to you. I can't do all these problems for you, right? But that's the concept I want you to understand. Okay, now it's very important to realize each of these line segments has a different delta x over delta y, and each of them has a different delta y over delta x, right? That just makes sense. Let's take a look here, right here. So from here to here, oops, what did I just do? From here to here, that delta y over delta x, that delta x over delta y, those two changes, they're different. There's a different ratio compared to from here to here, compared to from here to here, from here to here, from here to here, okay? And you can see that on the Desmos graph as well, you know, from here to here and so forth. Okay, so you got to be careful. You can't just find one of these delta y's over delta x and then think, okay, I'm done. Okay, so each one of them has a different ratio there. Okay, this symbol right here means I'm done. A little box, kind of a squiggly lines are dark. You see that in a lot of math books. That just says, okay, I'm done with this problem. Okay, so I hope that helped. If you want this handwritten solution, just send me an email and I'll send it out to you. Have a good day.